Hello everyone. Today we will start the basic concept of organic chemistry from class 11. And today will be the first class of this organic chemistry. Okay. Now let me clear one thing that simultaneously videos on basic concept of organic chemistry will be uploaded. That means from class 11. Again from class 12 it will be uploaded. 9 also and 10. Okay. So today will be the first video on basic concept of organic chemistry. Okay. Now here this chapter is very important, and from this chapter the organic chemistry actually starts. Okay. So we have to study this chapter properly and carefully. We have to study so that each and every topic should be clear. Okay. Now to go in deep into this chapter, before I will tell you about carbon, because carbon is the main element of this organic chemistry. Okay, carbon is the main element of organic chemistry, so we have to learn the properties of carbon. What are the behaviors carbon can show? That properties we have to learn. Okay, now so start from carbon. So symbol of carbon. Carbon is an element. Okay, and it consists of large number of atoms, smallest particles called atoms. So symbol of carbon is C. Okay. Now atomic number of carbon. Atomic number means the number of proton present in the nucleus of an atom is the atomic number. Now for carbon the atomic number is 6. That means electron number is also 6. Okay. Now come to electronic configuration. Electronic configuration. Now from atomic structure chapter we know that previously in class 10 the electronic configuration we used to write like this, that in k orbit 2 electron but in l orbit 4 electrons. But now we learn the concept of orbital. Electrons, we can find the electrons in maximum probability in orbital. That means the orbitals are those regions where we can find the electron maximum, that is orbital. That means probability of finding the electron should be maximum in the orbital. So electrons are there in the orbital. Now we know the orbitals are like this: s orbital, p orbital, d orbital, f orbital. Okay. So in k orbit there is only one orbital is there, which is called 1s orbit. Okay, and there only 2 electrons can be present. So instead of k orbit we have to write 1s2. That is the electronic configuration. Okay. In L orbit we learned that maximum number of 8 electrons can be there, but here in N orbit some orbitals are there, that is 2s and 2p. Now 2s has only one box, you can say, only one room. So in 2s maximum number of 2 electrons can be there, but in 2p there are 3 suborbitals are there. In each suborbital there should be 2 electrons. So in each suborbital 2 electrons, so in 3 suborbitals 6 electrons can be there. Okay, so the electronic configuration generally it is like this: 1s2, 2s2, 2p6, 3s2, 3p6. Okay, 3d10, 4s2, 4p6. Like this the electron configuration we will see. Okay, but here as the atomic number of carbon is 6, so electronic configuration is 1s. In 1s orbital 2 electron, in 2s orbital 2 electron, and 2p orbital 2 electron. Okay, this is the electronic configuration of carbon. Now from here we will discuss about the valency of the carbon. Okay, now valency means the number of electrons present in the valence shell. This is the general concept, the number of electrons present in the valence shell, that is the valency. But here we have to understand deeply, that means the number of unpaired electrons present in the last orbital or the last shell of an atom, it is the valency. So let's just expand the electronic configuration. In 1s orbital will be 2 electrons, so these 2 electrons can be present as upspin and downspin. One electron will be upspin, another will be downspin. 2s also upspin, downspin. Now in 2p 2 electrons are there, it will be filled up singly, 1, 2. This is 1s, 2s and 2p. This one is px, py and pz. Okay, 1s, 2s and 2p. Okay, Now this electronic configuration is in ground state. Now when the carbon is in excited state, that means it's going to take part in the reaction. That time it will show its valency. Okay. Now here from this electronic configuration, one can say that as the number of unpaired electron at the outermost orbital or shell, this is the outermost shell, and this one is paired, but this one is unpaired. So number of unpaired electron at the valence shell is 2. So valency should be 2, but it is not. Valency is not 2 for carbon. We know the valency of carbon that 4. That means carbon has 4 hands. Okay. What will happen here? One of the at excited state, one of the electron from the 2s orbital will go to the pz orbital of 2p. Okay. Pz orbital of 2p, px, py, pz. Now we know that if a orbital is half filled or full filled, it is stable. So in the previous case here in this electronic configuration, it was not stable because in p, highest number of electron can be there, it is maximum number of electron can be there, it is 6. So if 6 electrons are there, it will be stable, or 3 electrons can be there, it is stable. But here in the ground state electronic configuration, it is not 3 or 4 or 6. 2 unpaired electrons are there, so it is not stable. To make it stable, the one electron is went from 2s orbital to the pz orbital, and it is making its stability. Here 3 electrons, that is half filled, stable, it is half filled, and it is half filled. So both are stable, understood? So now in how many unpaired electrons? 4 unpaired electrons. 4 unpaired electrons. Okay. So this is the actual valency. So this question can come that though the electronic configuration of carbon is 1:2:2p2, but its valency is 4. Why? Because actual ground state excited electron configuration is 1:2, 2s1, 2px1, 2py1 and 2pz1. That's why it is showing the valency 4. Okay. Now as the valency of carbon is 4, so we can write that carbon has, this is the main topic, carbon has 4 hands. This one you have to remember. Properly you have to keep in mind. Carbon has 4 hands. So as carbon has 4 hands, so carbon will form a compound, okay, by taking 4 hydrogens. 4 hydrogens. First of all, we will see the compounds of only carbon hydrogen. Okay. So carbon can form compound like this. In 4 hands, it is taking just monoatomic element. Diatomic element. As hydrogen has valency 1, so it is taking only hydrogen. So whenever we will fill in the valency of the carbon, we should add hydrogen. So it is the first compound of carbon. Okay, it is methane. Simplest compound, that is methane. Now before going into the hydrocarbon or alkane, just I am telling the properties of methane here. The structure of methane here, it is tetrahedral in nature. Okay, you know, tetrahedral in nature. This structure is tetrahedral. Okay, and this carbon, that means central carbon, is sp3 hybridized. This central carbon is sp3 hybridized. Now how to check hybridization? We have to calculate the number of sigma bonds surrounding the central carbon. Number of sigma bonds. Hybridization calculation. Number of sigma bonds. Now, how many sigma bonds are here? Every single bond is sigma bond. So here 1 sigma, 2 sigma, 3 sigma, 4 sigma. Now 4 sigma means 1 s orbital, 3 p orbital, sp3 hybridization. So here the carbon atom is sp3 hybridized. Now from chemical bonding, we come to know that if the hybridization of the central element is sp3, then the bond angle, that means here HCH bond angle is 109 degree 28 minute, and the geometry of the compound is tetrahedral. That's why methane is tetrahedral in nature. Methane is tetrahedral in nature, and here HCH bond angle is 109 degree 28 minute, and hybridization is sp3. Okay, so every single bonded compound is sp3 hybridized. Okay. Now carbon, from its by its 4 valency, it can form chain like compound. Okay, so we have to prepare the structure of the compound. Okay, today we will discuss up to this, that means up to structure of the compound. Say this is methane, we know this is methane. Okay, now if we replace another hydrogen by another carbon, okay, now that carbon will have 4 valency, 1 2 3 4. Okay, now again add another carbon here, 1 2 3 4. So carbon can make this kind of chain like compound, and it is called catenation property. Okay, it is called catenation property, the property by which carbon can form chain like compound, huge number of compounds, that is called catenation property. The property by which carbon can form carbon-carbon single bond, carbon-carbon double bond, carbon-carbon triple bond, okay, is called catenation property. Okay, and from that property carbon can form huge number of compounds. Okay, huge number of compounds. Now one single bonded compounds I am telling you. This one is single bonded compound. Okay, single bonded compound. Double bonded compound. This is double bond between 2 carbon. Only one carbon cannot have double bond. There should be 2 carbon. Okay, now this carbon has valency 1 2. Carbon has 4 hands, so you have to add another 2 hand here in carbon, and here also another 2 hand. Now how to fill up the hand? Fill up by hydrogens. It is the first double bonded compound. It is C2H4, and it is ethylene. It is ethylene. The common name is ethylene. It is ethane. Now how to write the name of the compound? Nomenclature I will tell you next step. Okay, and triple bond compound is this one, acetyl. Okay, so today up to this. Next day we will discuss about the structure of the compounds. Okay, structure, how to write the structures of the organic compounds, how their bond angle changed, and what are the alkanes, alkenes, alkynes, IPAC nomenclature. Next day we will discuss. Okay, thank you.